Alright, so a bottle rocket's about 32 meters per second, and we're going to turn up this angle a notch. This is a huge angle, right? 85 degrees, and we don't need horizontal right now, but I'll just draw it in for fun. And we really need, so remember, we're going to attack how high first, and we need that vertical velocity to get started. So it's 32 times the sine of 85, and I'm going to get 31.9 meters per second. Okay? At the top of the path, my vertical velocity is 0, so I'm going to go Vf squared equals Vi squared, which is that, minus 2g change in y. My final velocity is 0, because at the top of the path it quits going up, it's not coming down yet. My initial, we just did 31.9 meters per second. That needs to get squared. I already threw the negative in for gravity. Can you tell I've done these before? And then times change in y. So I'm going to subtract 31.9 from both sides. That 0 is gone. That has to be squared. Then I have a negative 2 multiplied by 9.8 meters per second squared times change in y. We've been here, done that. I've got to get rid of these to the other side to isolate my change in y. Bye-bye there. Hello over here. So I'm going to go 31.9. I'm going to square it, divided by parenthesis 2 times 9.8. I have a negative on top, negative on bottom. I know that my answer is going to be positive, and I get a change in y, or a height, of 51.9 meters. That's how high it went. So I'm halfway done. Yay! Let's do how far. Alright, I hope it made sense to you that at this 85-degree angle, which this is not drawn to scale, 31.9 is almost the 32, so it should be almost all of that velocity is sending it upwards and very little is sending it far. So we're on how far now, which means I need this velocity down here in meters per second. So I can do 32 squared minus 31.9 squared, square root my answer, and I get a whopping 2.5 meters per second. D equals Vt because I'm in the horizontal world. 2.5 meters per second times time. When you need a horizontal time, you steal it from the vertical, but since I'm in velocities, I have to use this equation. I put the negative from the g built into that equation because it'd be plus minus. The beautiful thing of velocities is whatever it is going up at the same spot, it will be the same coming down except negative. My initial is 31.9 minus 9.8 meters per second squared multiplied by time. I have to subtract this from both sides, and I'm going to get negative 63.8 meters per second equals negative 9.8 meters per second squared multiplied by time. How do you get time all by itself? We are going to divide both sides by 9.8. And what I do to one side, I have to do to the other. Look at that. Negatives are lining up, so I get a positive time. 63.8 divided by 9.8, and I'm going to get a time of 6.5 seconds, which now goes up here. And when I times that, multiply that by 2.5, I get a distance of 16.3 meters. That's how far it went. You wouldn't think it would go very far because it was basically vertical. There was very little velocity pushing it far. Good? Good. Bye-bye.